Homework 9, question 3. So the question is, the x of t is the Poisson process with the probability of x of t is equal to k is going to be equal to the e to the negative lambda t times the lambda t to the k over k factorial. So prove or disapprove that limit when t goes to infinity that x of t over t is equal to lambda in probability. So for the Poisson process x of t, we know that the eta t is going to be equal to the expected value of x of t, and this is going to be equal to the lambda times t. And also we know that the sigma square, which is the variance of the x, is going to be equal to the expected value of x of t minus the eta of t and the solution squared. And this is going to be equal to the lambda times t as well. So the limit when n goes to infinity, the probability of absolute value of that x of t over t minus lambda is going to be smaller or equal to the epsilon, and which is equal to 1. And we also know that the limit of the n goes to infinity, the probability of that absolute value of x of t over t minus the lambda is going to be equal to epsilon is going to be equal to 0. So according to the Chebyshev inequality, we know that the limit of t goes to infinity, that the probability of x of t over t minus the lambda absolute value of this bigger than epsilon is going to be smaller than the limit of t goes to infinity, that expected value of absolute value of x of t over t minus lambda squared over epsilon squared, which is equal to the limit of t goes to infinity, that lambda times t over t squared times the epsilon squared is going to be equal to 0. So because of that, we know that the limit when t goes to infinity, that x of t over t is going to be equal to lambda, which proved the equation from the question.